Hi, everybody. We've hit the top of the hour. This is the hackathon closing session. I still see the participant number increasing a bit, so I think I'm going to wait a couple of minutes and see, let that settle down, and then we'll start the closing session. Okay, it looks like the numbers have settled. Welcome, everybody, to the closing session of the IETF 111 hackathon. I hope everybody had a great time. All the feedback I've gotten is that it's been a good hackathon. And I'm sorry we had to do another one of these online, and I hope we can do one in person again soon. But in the meantime, welcome to the IETF hackathon closing. So we've done all of this, the agenda, the note well. What we mostly have to do today is the project presentations. So again, we're looking for short presentations, of which it looks like we have about 10 posted, talking about what problem you tried to solve, what you accomplished during the week, and some highlights of what happened, lessons learned, what feedback you have to bring back to working groups, and what impact on open source and other SDOs you have. So here is the URL for the page to submit your presentations. If you haven't already, I will try to accommodate you if you post them now, but we're going to go through the presentations that are there first, and then we'll see what we have. And that's it. So let me change my sharing and share the page with that. Let's see, stop. Okay, so that should be it. And let's go to the first presentation. We're going to start with BMWG container benchmarking. Grab that. Okay, I guess I need to share that. All right. I'm learning this as I go, having not done this remotely yet. So, sharing. And here's the PowerPoint. I do wish a double click worked, but it does not. Here we go. All right. Go ahead.
Okay, good. Can you hear me?
Go ahead. Just say next, and I will change the slides.
Okay, so yeah, so let's start. So hi, so my name is KJ Sun, so from Sungsil University. So today, so I'll talk about our hackathon project BMWG containerized infrastructure benchmarking. So our hackathon project have been worked from the IETF 106, and we maintain our main goal is to implement container benchmarking environment with various networking models and compare network performance with various impacting factors. So all the results and the discussion during this hackathon are using to update our BMW draft. But unfortunately, the current our draft state was expired last month. So in this time, we had one more goal, which is to discuss for updating our draft to 06 version. Okay, the next slide, please. Yeah, so this is the contents in the hackathon wiki page. So our team is organized from the Sungsil University in the South Korea, and then co-working with the I2NSF and IPWeb team together at the ITF Korea Forum. In this hackathon for benchmarking, our main goal is to verifying packet loss performance between different acceleration technologies, which are VPP and then DPDK OVS and SRIOV. And then we estimate that the VPP and OVS DPDK use different pre-switch entities and the packet processing mechanism. So there may be performance gaps of throughput as well as packet loss at the switch. And then another goal is to verify NUMA affinity impact to networking performance. Actually, this work was done at our previous hackathon actually. But at that time, our test was not correct because our understanding of container networking model was not good. We tested it again. And then there was the NUMA testing report from other community, which is the VINPUF of the Anuke project. So we tested following their test methodology and then verifying in our testbed environment. So at the same time, so we discussing about the draft update. Okay, next slide, please. Okay, so I briefly talk about the draft update discussion and then move to the testing. So in our previous draft, so we found that there was some clear definition and the figures for describing container networking models. First we survey and then discussion in this hackathon, and then we reclassified the container networking model with a pre-switch aspect. So also for describing performance impact factor in the containerized environment. So we gathered the benchmarking experience of our testing as well as testing done from other communities. So it was very useful to us to make our draft more clear and then contribute to the BMWG to bring the considerations of the container benchmarking. Okay, next slide, please. Yeah, for real testing, so first we made our testbed with different acceleration technologies. So we used the 3 accelerations, which is the OVS DPTK, VPP, and the SRIOV. So for all cases, packets from the external traffic generator are bypassing kernel space, and the all packet processing is handled at the user space level. So we firstly testing performance from baseline, and then especially we try to test packet loss between the OVS DPTK and then VPP. For making the multi-interface container, we use the multi-CNI to make the vhost user interface and the SRV VF driver interface. And for traffic generator, so we use T-Rex on the bare metal server, and between testing server, there was no switch or hub between the 2 servers. Okay, next slide, please. Yeah, so the second testing was to compare the network performance with the different NUMA affinity, which allocates CPU cores for vSwitch and the container to the same or different NUMA node. So you can see the 4 different core allocation scenarios in the slide. So the oldest scenario, we tested performance with OBS and then VPP. Okay, next slide, please. Yeah, so these tables are showing the specification and then configuration of our testbed environment. So for testing, we used the 10G NIC card with the SRV functionality. And then for CPU allocation, so it was enabled to provide the hyper-threading technology. And then you can see the configurations in the tables. Okay, next slide, please. Yeah, so as the results, so these graphs are the result of the NUMA affinity test. So the upper two graphs are throughput result in the VPP case, and the lower two graphs are the shown OBS PDK result. So and each graph includes the four scenario with the different NUMA affinity. So compare with the two different networking technology, the VPP performance results show much better than the OBS PDK result. And in both cases, the results show that allocating same NUMA node or vSwitch cores and then container cores is more effective for the improving the network performance. Okay, next slide, please. Okay, so this is for the benchmarking summary. Actually, for packet loss measurement, so we cannot make any useful result because whenever we try to measure with the packet loss with 110% of the throughput based on the methodology, but our results were not the consistency. So we have some issues raising about the T-Rex, having some problem to drop packets. But at this time, we cannot say it is exactly T-Rex problem. So after this hackathon, so we will keep work on these issues. And then the NUMA affinity testing was the result that the most we expected. And it has some performance degradation compared with the BIMPOF test report. But it was some reasonable because we tested in the less resources that than their environment. However, even we consider some scaling, but the performance was quite worse, which is some kind of terrible to use, especially in case of the small size packet. So we will check again the testing methodology and then environment and configuration, and then we improved our some testing result. So based on this hackathon, so our future work is to bring that experience and the discussion by updating our draft. And at the same time, so we want to make some opportunity for discussing with other the related communities for the container benchmarking. So from that, so we hope that it may bring some improvement of our BMWG work. Okay, next slide, please. Okay, so this is the last slide, and then these are the participants of our team. And then it is made up the Sungshu University, and then thanks to the IETF Korea Forum to make the joint hackathon local event, and also with I2NSF and the IPWave team. So follow the Git link in the link, so you can check all some environment configuration related to files for our hackathon project. And then we hope to meet IETF at the on-site hackathon as soon as possible. Okay, so this is the end of my presentation. Thank you for listening.
Are there any questions for KJ? Okay, the next up is I2NSF. Thank you, KJ. Nice presentation. And the next one is I2NSF, which I'm going to bring up now, so get ready. And after that will be IP waves, so you can be on notice. Okay, here is I2NSF. And do we have somebody presenting the I2NSF presentation?
Okay. Hello, Larry and Pars. This is John Porja. Can you hear me?
Yes, we can hear you. Thanks.
Okay, let's start. Let me start. Okay.
Yes.
Okay. This is the Hackathon project for I2NSF working group. So the champions are me and my PhD student, Patrick Ringa. Let's move on. Next slide, please. So this is the poster for this hackathon project. Next slide, please. So our hackathon project, we want to demonstrate the latest version of NSF monitoring interface data model and also security policy translator. This time we demonstrated two features. The first one is automatic data model mapper for the I2NSF security policy translator. The second feature is to support real-time monitoring data visualization via web-based monitoring. Next slide, please. This figure shows the I2NSF framework. Basically, the analyzer collects NSF monitoring data from NSF below the figure, and then an analyzer visualize the monitoring data to detect the security attack. And then that information will be delivered over application interface, and the security controller will update or generate a new policy accordingly, and then the new policy will be delivered to NSFs. Next slide, please. So basically, what got done this hackathon project? Left-hand side, this is the architecture of a security policy translator. So this time, we made a new component. That name is a data model mapper between high-level data model and low-level data model. Next slide, please. So the first task is automatic data model mapper. Like this figure, left-hand side, we have two data models. The first one is consumer-facing interface data model, which means the high-level young data model. And also below that, we have NSF-facing interface data model, which means low-level young data model. So basically, we want to map between variables of high-level young module and low-level young module in terms of young trees. So basically, we are using a Zhang-Shasha algorithm to calculate the tree edit distance to minimize the distance between young variables as the tree nodes, and then we can map. Next slide, please. The second task is real-time monitoring data visualization. So you can see this web browser displays real-time URL filtering resources data. So the upper graph is the computing resources such as CPU, memory, and disk utilization. And then the below figure is the input and the output data traffic. So in this scenario, we intentionally made the DOS attack, and then we can observe the input data curve, the significant increases, and then we can determine this is a DOS attack. Next slide, please. So what we learned this time, and then we learned the security policy translator can be supported by automatic data model mapper to facilitate prerequisite setting for translation. And also the monitoring and data visualization can support the monitoring of multiple NSFS in real time in terms of computing resources and traffic. Finally, with this monitoring data visualization feature, we can perform the analysis of an NSF behavior, such as security attack detection. Next slide, please. Next step, we also enhance the security policy translator in terms of context-free grammar, auto construction. Basically, this one can partially aid the generation of low-level young XML file using this context-free grammar based on NSF-facing interface data young model. And also we can improve NSF, I2NSF analyzer with machine learning to detect the new security attack. And then we can update or create a security policy. Finally, we want to migrate from VNF-based virtualization to container-based virtualization for I2NSF. Next slide, please. This is open source project at GitHub. Next slide. And also, we uploaded demonstration video clip at YouTube. You can see the performance measure. Next slide. So we built a team with Sungsil University and Atri and Gyeongbu National University, along with my SKKU team. So our I2NSF team worked with the IP Wave and the benchmarking working group hackathon project this time. Next slide. So we got multiple supporters, such as the sponsors from NRF, IETF, TTA, and also IETF Korea Forum. Next slide. So this is the portal for our I2NSF and the benchmarking working group and IP Wave hackathon teams this time. Thank you for your attention.
Any questions for Paul? All right, thanks for the presentation. And the next one up is IP Wave, and after that will be BMP Yang. So you can get ready, and I'm going to set up the BP Wave presentation now. I'm sorry, the IP Wave presentation now. Okay. Okay, I have to do it to get out of full screen first. There's the IP Wave. Now I can go to full screen. Okay, IP Wave is ready. Go ahead, Paul.
Okay, thank you, Larry. Okay, this is IP Wave Basic Protocols project. The champions are me and the Dr. Ivan Christian. Next slide. So this is the poster for our IP Wave project. Next slide, please. So basically, the last hackathon project, IETF 110. So we demonstrated the feasibility by UDP-based mobility information sharing. So as you can see, two robot vehicles, which means AI on robotics R1 model. So we allowed the message exchange between two robot vehicles using UDP. So the CCM and the ECM. CCM is a correlation context message for regular driving, and ECM is urgent emergency context message to detect some obstacles in roadway and then advertise the message to neighbor vehicles to avoid accident. Next slide, please. This time we want to demonstrate IP version 6 neighbor discovery message for sharing mobility information among vehicles using new ND option, neighbor discovery option. It is called the vehicle mobility information option, VMI. So it contains a GPS coordinates such as latitude and longitude, speed, and direction. So our question is how to design a new ND option for VMI and how to test the ND option. So we have several references, including Linux LawSocket and also RFCs and Internet Draft. So for the proof of concept POC, we use the LawSocket-based ICMP version 6 to design and test the new ND VMI option. Next slide, please. This figure shows our new ND VMI vehicle mobility information option. So this option is described in the following two draft. Next slide, please. This shows Linux kernel ND data structure, basically using existing Linux ICMP version 6 neighbor discovery advertisement message, and then we can construct the VMI option message. Next slide, please. We demonstrated IP version 6 NA VMI option. This message includes GPS location information such as latitude and longitude in Busan, Westin Joseon Busan Hotel in Korea. Next slide, please. What got done? We tested IP version 6 neighbor discovery in the LawSocket-based ICMP version 6 by open source code. And then we demonstrated LawSocket is a feasible approach to test a new IP version 6 ND option. In the last time, we tried to use the kernel, the modification. It is not easy. So this time, we showed the feasibility of a LawSocket approach. So we tested two IEEE 8.11 OCB enabled laptop to exchange NA messages that include the VMI option. Next slide, please. As you can see, the sender transmit VMI option message including latitude and longitude in Busan, and then receiver node. Okay, this is a neighbor beaker displays the transmitter sender's coordinate. Okay, next slide, please. So what we learned, you can see two laptop computers are regarded as two the beakers. So we introduced the NA message exchange for sharing vehicle mobility information. So to support this feature, the existing neighbor discovery process needed to be updated by defining a new option type a different mechanism for sending neighbor advertisement and a neighbor cache dedicated for this new option. Next slide, please. Next step, we will apply our implementation of ND-VMI option to robot vehicle. That is AI on robotics R1 model. We will implement and test our context-aware navigation (CMP) service in such robot vehicles. Also, we try to design and implement this option with IP version 6 over 5G V2X interfaces. Currently, we are using DSRC interfaces. Next slide, please. This is an open source project at GitHub. Next slide, please. We also demonstrated our implementation. So you can see our demonstration video clip at YouTube. Next slide, please. So this hackathon project is a collaboration work with the Sungsil University and Busan National University and Gyeongbuk National University. This is a total of our active hackathon members. Our IP Wave hackathon team work with the IETF and BMWG hackathon teams this time. Next slide, please. We have multiple sponsors such as NRF, IETF, PTA, and IETF Korea Forum. Next slide, please. This is our teams for IP Wave, I2NSF, BMWG hackathon teams. Thank you for your attention.
Okay, thank you very much again, Paul.
Thank you.
Any questions for Paul about IP Wave? Okay.
It looks like Nick, you're in the queue.
Yeah, sorry. Go ahead, Nick.
Hi there. Thanks so much for sharing the work. I'm not familiar at all with the vehicle information sharing, but it seems pretty exciting. I was just curious if you either this week or in general have done some work on the security and privacy considerations. It seems like potentially sensitive revealing data that might be shared and could potentially be misused in different ways. I was just curious if you had some initial work on that.
Okay, right. That is a good question. So the information of the location of vehicle may be a privacy issue, but our goal is to share the location of vehicle to support collision avoidance for driving safety. So also we can consider authentication mechanism to protect this message in near future. Thank you.
Okay, Brendan. Brendan, go ahead and unmute yourself.
There we are. Yeah, no, I attempted to, and it took a moment.
Okay.
So this is essentially going to construct the same issue as we have with automated number plate readers. So anywhere that you would consider an automated number plate reader to be an invasion of privacy, anyone with an appropriate antenna will have the same thing. And unfortunately, authentication on its own is going to be difficult to make adequate because anything that needs to do collision avoidance will need to have that authentication information. And I see this as a very difficult mutual authentication problem to actually get right without having substantial cryptographic setup before you can actually exchange data. And in a collision avoidance scenario, the latency required to do that sounds problematic.
Interesting. Thank you. Paul? Okay. Okay. So Thomas, is this more questions for this, or are you the BMP and Yang guy?
Yeah.
Can you hear me?
Yes, we can.
Okay, excellent. So I'm Thomas from the BMP and Yang Hackathon group. Next slide, please.
Just before we go on, we missed
Oh, sure.
Big Bang, so be prepared. Okay, next slide. You have it.
Great, thanks a lot. So this time we were focusing solely on testing the performance on BMP, the impact BGP monitoring protocol has on BGP and on CPU and memory usage on the route processors. There, especially in context of BMP adjacency RIP in, out, and the local RIP with path marking and traditional TLVs. We were testing if there is a difference when the BMP session towards the collector is stable, unstable, and also while if it makes a difference if the peers are flapping or not. And also we were curious about the BMP route monitoring messages, if we can actually measure the delay across the BGP propagation, and if it's always ensured that we have the complete view of the BGP RIP state. Next slide, please. So we were using PMA-CCT for data collection, Kafka as a message broker, Druid as a time series DB, and Pivo for actually accessing the data, and Wireshark for the BMP dissector, and ExaBGP for generating the routes. There is a link with the small tutorial how you can set up your own environment. Next slide, please. So this is the network we used. So we have on the very left-hand side the ExaBGP generating the VPN-v4 routes, where the Juniper router is basically the route reflector, and we were measuring adjacency RIP out, so basically the advertisement towards the Huawei route reflector, where we are measuring adjacency RIP in pre-policy and adjacency RIP out post-policy, and then importing the routes on two different MPLS PE router on Cisco iOS XE and iOS XR. The test bed was generating 1 million VPN-v4 routes as fast as possible. And on the route reflector, we were supporting adjacency RIP in, out, as well also the path marking and TLV drafts. Next slide, please. So what we achieved this time is that the automation continued. So we continued to improve the test bed. So now including also different scenarios where we have like a stable BGP environment versus also initiating the peerings again, so we can compare what's the difference between the two. We are measuring through Yang push the CPN memory consumption on the BGP process, and have now also a comparison between the 4 different operating systems. Our next step will be to scale up using now also Cisco iOS XR and XE as route reflectors and MPLS PE routers, and we are looking forward for an improved timestamping on the Huawei VRP. Next slide, please. Speaking about timestamping, so these timestampings have been improved in the wire. So this time also iOS XE is able to expose metrics with seconds and milliseconds timestamping, and we are looking forward on the Huawei VRP side that millisecond is supported as well. That's important because we want to measure the end-to-end propagation delay impact when BMP is enabled. Next slide, please. We were mostly using Yang push, different Yang models depending on the operating system were available. On some operating systems, it's not yet available to measure that on a process level. So we are used screenscaping CLI to get the data. Next slide, please. So here, just a comparison on the left side, basically when on the central route reflector, either BMP is turned on or turned off. You see a slight difference in the BGP propagation delay. So the scale is how much prefixes within a second are being propagated across the network. On the right-hand side, you can see basically the same, the comparison BMP on and off on the central route reflector, but compared to the left side, on the right side, we were basically flapping all peers on the route reflector. Next slide, please. Now, same thing, but now collapsed on one graph, so the difference between BMP on, off, and flapping. Next slide. Here, we are looking at the impact on the route reflector in the middle in terms of memory and CPU. So you can see in the middle, so at 1000, we were basically flapping the peer. So you can see basically before and after the flapping, the difference if BMP is turned on or turned off in terms of CPU and memory utilization. So you see there is not much of a difference. Next slide, please. Since we were measuring the end-to-end delay across the route reflector, this is basically on the Juniper router. We can see how much the impact is, or basically when we leverage that BMP turned off, turned on the central route reflector, what impact it has on the remote routers, and there is virtually no difference in terms of memory and CPU. Next slide, please. Also the same on the MPLS PE routers. We don't see much of a difference. It all depends very much on when you're in a congestion, how quick the data collection can keep up. Next slide, please. So what we learned again, it's not the first time, that good preparation and test automation was very important. On the test bed side, we are, let's say, we noticed we need to improve in terms of scalability. If we are going towards 4 million routes, we saw some instability, and we need to increase the performance on the data collection and the big data side. And yet again, because it was virtual, we're missing the beers and the cocktails after. Next slide. Thanks to Alex, Pia, Paolo, Marco, and Matthias for joining the hackathon. It was a pleasure again to work with the team together. That's all. Any questions?
For Thomas.
Sure.
Yeah, Thomas, I think we're all missing the beer and cocktails after and the other socialization that goes along with it. So, all right, thank you for your presentation.
Thanks a lot.
The next step is Big Bang, and after that, we will have ID visualizations. So let me get Big Bang started. And Big Bang is here. And let's go into that. Full screen. Okay. Carry on.
Hi, everyone. Good to see all of your projects. I'll be talking about Big Bang today. We've talked about this at a few hackathons in the past. So if you guys just go to the next slide, I'll talk about what it actually is. This is an open source project, a sort of scientific toolkit used by a lot of researchers for studying collaborative communities, open source projects, and a lot of internet governance groups. We pull in lots of data sources, email, Git, data tracker, that sort of thing, and then use the scientific Python stack to do various analysis on that. And so we've been applying that to IETF with its very long-running mailing lists and lots of data. If we go to the next slide, we talk about the plan. This time around, we had a slightly smaller group, but we were trying to add new data sources, getting mailing lists from a couple other fora, 3GPP and IGF, which were of interest to a couple of researchers. And then we're trying to connect the data tracker and maybe GitHub as new data sources. And that's to get at the sort of research question we wanted to look at more this time around about organizational affiliations of participants and the email domains. So if you go to the next slide, we can start looking at some graphs. Yeah, this is two IETF mailing lists, DOE and the IETF privacy discussion list, where the x-axis is the number of participants and the y-axis is the number of messages, and each point is an organization. We've inferred the affiliation through the data tracker, and then you can see, and I've tried to classify them roughly into corporations, academics, and nonprofits. And so you can see maybe what is not too surprising, that many corporations are sending more participants, but also that occasionally a nonprofit or an academic group might only send 1 or 2 people, but send quite a few messages. So that's just a couple of mailing lists, and hopefully we can apply that to a larger set of data. On the next slide, we can see some other work done on 3GPP. So this is a similar kind of analysis, except just using the email domain rather than using the data tracker and document authorship to figure out affiliations. And they've also looked at time zones. Christoph mapped the time zone of the mail sender to see where participants are sending from. That might be something we should try to apply to IETF data as well. And then the next slide has another graph. This is looking at participants based on email domains, and to look at the sort of standard deviation, how much of a range there is within a single domain about how many messages are sent to a particular mailing list. And so Seb Benthal is working on this, hoping that we can maybe do some machine learning to do some inferences based on different domains and how they send different patterns of messages to a particular mailing list. So those are our graphs. Hopefully we'll be able to build on that in the coming months. On the next slide, we have a few lessons learned. Yeah, or relearned. I appreciate that was one of the other presentations. All data is messy. We always see this. It's always a surprise, even though we see it every time. On things like organization and affiliation, those are very messy concepts. The data tracker, thanks to everyone who helps run the data tracker. That has some great data. The API is providing us useful things about affiliation and document authorship. We also connected to GitHub, but that seems a little less promising. Lots of people's affiliations are changing over time, particularly at IETF. And so that will be useful to look into. And then one challenge about the remote hackathon, we were all in different countries. It's much harder to debug someone's Python issue from a long way away. Finally, on the last slide, these are our team members, and you can follow this link about the research project, and we welcome both contributions and also research questions. If there's something you've wanted to know about IETF participation, we have some tools and want to look at that data. Thanks, everyone.
Okay, thanks. Thanks, Nick. Any questions for Nick?
Yeah, actually, I had a question. This is Charles, and the question I had was in regard to GitHub, and I don't know if you saw any instances where people were having automated messages from, like, when you do something in GitHub, it sends it to the IETF list. I don't know how prevalent that is, but did you encounter that, and just how are you dealing with that?
That's a great question. I haven't run into that problem yet, although I am prepared for it, because yeah, there is often that case where we're assuming that an email address always refers to a person, but yeah, like updates from GitHub might look like they're from a person, but actually be from a robot. And we also see that like there's often an outlier in many of the larger analyses for sort of like administrative email addresses from the IETF, right? Whenever they send an announcement of a new draft publication or a meeting request, something like that, there's often an outlier where it looks like the most active person is internetdrafts@ietf.org. So that's one of those messy things we have to clean up, one of those outliers.
Thanks.
Okay, anything else? All right, thanks, Nick. Appreciate that. And next we have ID visualizations. Somebody up to present for that? Okay, here we go. Go for it. Just say next when you want the next slide.
Cool. Thank you. My name is Kesara and IETF newcomer. Can you go to the next slide, please? So problem I tried to tackle was to visualize how people have contributed through internet drafts over the time and how different working group has evolved over the time. For that, I used a program called GOES, which is used to visualize how people have worked on a GitHub repository. And what I try to do here is to simulate a Git log from internet draft data. Can you go to the next slide? And there should be a nice image, but it's missing, but that's all right. So I used BibXML3 reference data, so that has author's information, draft dates, and the draft name. So I derived the author information as authors as committers, and then from the ID name, I put those drafts into a directory structure that's, for example, for an IETF working group draft, it will go under IETF, then the area, then the working group, and then the draft name. And after that, the draft revision with the name as a file to simulate a Git log for that draft. Can you move to the next slide? And can you click on the play button, please? I apologize for the poor choice of music there, so I just used the music that. Maybe it's better to pause it now. So that didn't go well. Anyway, so feel free to watch that video later and mute the music. From the video, so you can see like one big cluster occurring for individual submissions, and then based on a number of drafts for a working group, there are different colors assigned for different working groups, and they are forming their own clusters. And can you go to the next slide, please?
Trying to, it looks like it's trying to replay the video. Wait,
you had to click outside the video.
Yeah, I'm just doing that now. Okay, got it.
Good. Thank you. And if you go to that GitHub project, then there's a list of links for different work groups from the beginning of date, from BibXML data on how those work group areas has evolved over the time. And there's another video I generated for 2021 for all the draft submissions, including individual ones and the other working group based submissions, to see how that evolves and how people have contributed over the time. And that's it. Thank you.
Okay, Kesara, thank you for this, and welcome to IETF participation. Nick, you have a comment?
Yeah, I'm just really excited to see other researchers working on the IETF data itself, on the drafts. That's great. Have you looked at the data tracker API, or can we help connect you to that?
Yeah, someone brought that to my attention, that I can use the data tracker API. I will be looking to make use of data tracker API in the future. So here I just use the data source that I knew about. But
Oh yeah,
yes,
absolutely. Not a critique at all. I just wanted to make sure that we're sharing.
Yeah, so that will, thank you. That will be more accurate, because data tracker would have the actual submission dates and more information that I can gather from that.
Awesome. Well, I look forward to it.
Thanks.
Thanks again, Kesara. And I'm sorry, I forgot to say that the next up is ASDF. And here is the ASDF presentation all ready for you. So Karsten, go for it.
Yeah, can you maybe reload?
Reload.
Because that's not the one on the GitHub.
Okay.
But I can talk while you do that. So this is a small group that worked on related subjects having to do with the SDF data format, which is intended as a semantic definition format for describing IoT devices, their data models, and their interaction affordances. And the point of this work is not to create semantic definition format number 16, but to make that useful as a hub for translating between the various ecosystem-specific formats that are already out there. So the value of the whole thing rests on whether we can convert to and from SDF into the various ecosystem-specific formats. And
Karsten,
yes?
help out on getting the right thing. I'm in the GitHub, but how do I get the presentation you want?
You can download the HTML.
Well, that's what I thought I did, and that's what you said wasn't what was there. So
yeah, when did you do that?
right before we started. Oh, you updated it. Okay. All right, let me try this again then.
Okay, sorry.
That's okay.
Yeah,
Okay.
so one of the formats, one of the modeling formats that people here in the IETF are probably familiar with is Yang. So that's one target for the converter work. There is a W3C activity called Web of Things. There is a Microsoft thing called DTDL, and so on. So the point of SDF is to be useful as a hub between all these formats, so that you can take a WOT description, convert it into SDF, and then convert it into a Microsoft description, and so on. So that's the background. Slide 2, please. And the objective for this week,
yeah. Okay.
the objective for this week was to bring together the people working on the various converters. And of course, all these converters have a set of common or similar components that have to do with ingesting and processing and generating SDF. So it's useful for people to talk to each other. And we also wanted to produce some tangible results. The main result of a hackathon like this is that people talk to each other and understand what the other person is doing. but the tangible result is that we want to come up with some continuous integration modules that one DM, a group that tries to harmonize IoT models between ecosystems, can use in their model adoption process. So the idea is that if you have a great model for a fridge or light or light switch, you can send that to 1DM and there people can look, are there similar models? Should this maybe merged? Is there something that's missing for people being able to convert between their models? So that's our target organization that we are trying to do things for. The main problems this week were, number one, we have way too many programming languages and platforms. Actually, we are not aware of 2 projects that use the same language. So it's not like everything here is written in Python. Somebody is actually using Python, but everybody else is using something else. And that's, of course, also related to the fact that we have some constraint devices that may want to make use of that, and that may be hard in Python. And the other issue was that everybody is on vacation this week. So this was a particularly hard week to get people to join. Slide 3, please. So despite all this, what we actually got done was we now have a better shared understanding of how SDF actually works. And we have various improvements in the individual converters that were brought to the hackathon. And most importantly, we have those prototypes of the continuous integration modules. Those will allow using GitHub actions for the CI, so you can clone or fork the 1DM repository and throw your own stuff in there and see what happens. And I think that's a really useful thing to have in the long run. We have learned to look more at round tripping as a test strategy. And one issue with round tripping is that after a round trip, it's really hard to decide whether you still have the same thing. So you need some comparison function as well. We also had some interaction with the W3C. They have a meeting this week and probably will have another meeting next week, and we're trying to integrate some of their work with our work. Slide 4, please. So on the what we learned side, I think the biggest surprise was that we didn't have big surprises. So it all worked relatively smoothly in the direction where we thought we would be going, but it's clear that we need to talk about APIs way more. So it is said that the IETF doesn't standardize APIs, which is, by the way, not true anyway. But I think we need more focus on APIs, or at least design patterns for shared libraries, if we don't call them APIs, that ingest SDF and do various processing and validation steps on them. And the next thing we found is that there are 3 things that are difficult in computer science, and one of that is naming things, and we're hit by that as well. So we have to do a little bit more work about namespacing and using JSON pointers for that. And finally, a piece of new work that we probably will take to the working group is this SDF design for dynamic action objects. We already can do that in the ACE working group's authorization information format, but we have to make sure that similar things are possible in the other components working together. And in particular, we also have to talk about errors, because if you have physical interaction, you have unexpected things happening. Slide 5. So this was a small group of 4 people, 2 first-timers among them, but we also could stand on the shoulders of the people, of at least 2 people who were on vacation, Ari and Jana, whose tools we used and which are linked in the various notes we are taking and in this slide. So we were 6 people, 4 of them present, and made a little bit of progress. Questions?
All right, thanks, Karsten. And again, pleased to see a couple of first timers there. Anybody have questions for Karsten? Okay, that's all the presentations I think we have. Does anyone think you posted a presentation that I did not bring up? Brendan.
Hi, yeah. I thought that there was one for suit, TEEP, and lightweight M2M.
I don't see it here, but
I'm not sure Hannes uploaded it.
Oh, I thought
Is Hannes around?
fairly certain Hannes did upload it.
okay, I don't see it in the Hackathon 111 project presentations yet.
Okay, it was listed on the closing. I guess it didn't get uploaded.
Okay, do you want to feel free to talk about what you guys did? If you have slides, you can email me. I can get them up quickly, and if not, you can just talk.
Yeah, I can get those slides emailed over to you right away. Just a moment.
Right, because you could even share your screen.
Right, you could
yeah,
do
whatever.
that. You could just share them yourself if you want. That's true.
You should have them momentarily.
Okay, I can do that. Refresh my mail. You send them to the hackathon list or what?
Oh, I sent them to barryliba@computer.org.
Okay, I am refreshing my mail. I am waiting for it. Email as usual is a best effort thing. Why don't we just? Do you want to go ahead and just?
Yeah, sure. I
share
can get going with that. So it was software and firmware updates for IoT devices. The hackathon plan that we started with was to get software and firmware to the well, item 1, get software and firmware to a device. Now, for constrained IoT devices, the plan is to use lightweight M2M with OSCore security for CoAP. And for regular IoT devices, use TEEP for trusted app update on TEE.
I got the slides. I'm bringing the slides up now.
Oh, you've got them. Excellent. So next slide, please. Then the idea was to secure the update using the suit manifest and then use the new software or firmware. Next slide, please. So we identified a few issues with the TEEP protocol, which have been posted to the TEEP GitHub. We started work on integration of OSCore into Lashan, which is a lightweight M2M server, and Wakama, which is a lightweight M2M client, and that's still in progress. Tested registration with the Wakama client to the Lashan server using OSCore, and there's a couple of links to the GitHub for getting this done. And then we also started suit integration in MCU boot, and that's still in progress. So there's a few bits that are going on there, and you can see the different parts that we've worked on in the repos that are listed there. Next, please. So we learned a lot. We had great interactions despite the online nature of the event, but of course, regular work disturbs the flow, and our plan was too ambitious as always. And secure bootloaders turn out to be substantially more complex than you might think. And the testing of bootloaders, as it turns out, is substantially different than protocol testing. And then we want to thank Matt Gilmore for suggesting lightweight M2M as a theme. It was a great way to sort of get more people involved and work with different people. And so for a wrap up, we've got the various team members, and there were some additional people helping out from a variety of other working groups. And well, I guess in the case of Lightweight M2M, more than just other working groups. And that's about it.
Thanks, Brendan. And great that you guys got the Lightweight M2M organization involved as well.
OMA, I believe.
Yeah, OMA. So any questions for Brendan? Okay, I guess that, does anybody else have a presentation that I did not show? Okay, then I think that wraps up the wrap-up. I wanted to, well, let's let Charles make what comments he wants to make. Go ahead, Charles.
Yeah, I just wanted to get on to say thanks to everyone for joining the hackathon and very fantastic job running it. Thanks, really appreciate that. I was had another standards meeting going on the same week, so I wasn't able to be as involved in the hackathon as I typically like to be, but it was great to be able to see that so much great stuff happen. And I wanted to show off my hackathon shirt too. So.
Very cool. And I guess we should thank ICANN again for their support in sponsoring, and thank all of you who participated. You really made the hackathon work. And I'll say once again that Charles and I are both listed as co-chairs of this hackathon, but Charles is the one who does all the work on this. So thanks so much, Charles, for putting these things together and having done so from the beginning.
Oh, certainly my pleasure. And hopefully, I don't know, we'll see, we'll find out pretty soon, I guess, what's going to happen for 112. But we'll have a hackathon one way or the other, so.
Yes, we will. So either in Madrid or online, we will see you in November, and we'll see most of you next week online during the IETF meeting. And that's a wrap.
All right. Well, thanks, everyone.
Thank you.
Have a good weekend.
Have a good weekend.